All right. Now I want you to do conversions my way. Right? However you were taught in biology most likely was wrong. So I'm going to teach you the right way to do conversions. And if you learn it today, you'll never have to do it again. So make sure you do it this way. None of this, how many decimal places do we move, or the stupid little step thing. That stuff is all wrong. This is the right way to convert. All right, before I get how to do conversions, a few things I got to give you. So first off, standard units. This I just want you to write down, and then I'll get back to it later. 4 of them. Length. Standard unit is the meter. Time. Standard unit is seconds. Volume. It's liters. And mass is kilograms. So ideally we try to get everything into these units. So if it's in years or hours, you try to convert to seconds, so on and so forth. Most other units can be built from these things. The units you see in physics, like joules and newtons, things like that, are made out of combinations of these. There are a few other basic units. Most of them have to do with electricity. We're not going to talk about them. Okay, so leave that aside, ignore that. Now what I'm going to give you is very important. This table you are going to refer to throughout the year anytime you have to do conversions. These are the prefixes. Now after you write this, I want you to skip down about 1, 2, 3, 4, 5, maybe 6 lines down. And then 6 lines down right in the middle, I want you to write this. I want you to write 1 meter equals 1 meter. Which of course is kind of redundant, but I want you to write it in there. Also that equals 10 to the minus, or 10 to the 0 meters. All right, so going up from here, next line above this, you are going to write 1 kilometer or kilometer, however you want to say it, is 1,000 meters, or 10 to the 3rd meters. Next one up is 1 megameter. That's 1 million meters. Or 10 to the 6th meters. Now, not all these units do you see with distance. Like this says gigameter here. You don't usually see gigameter. For large units of distance, you either see astronomical units or light years. But you do see giga for other things, gigahertz, gigabytes, right? So for frequency or for storage space, we do see them. Giga is a billion, or 10 to the 9. And what am I doing? 1 more, 2 more. Okay, last one is tera. Tera you only see really with computers for memory, for space, storage space. Tera means a trillion. So terabytes you might have heard of. I'm not actually hearing what you say terameters. Okay. So that's as big as it gets, or as big as I'm going to give you. Now we're going down, below here. So the next one down is going to be 1 millimeter, 2 lowercase m's. Megameter was capital M, lowercase m. This is 0.001 meters, or 10 to the minus 3. Below millimeters, am I going too fast? That's good? Okay. Below millimeters is micrometers. This thing here that I just drew for you, it's a Greek letter. If you're actually Greek, you would call it me. If you're American, you would call it mu. It looks like this. So micro is what it stands for. So 1 micrometer equals 0.000001. So that's 5 zeros after the decimal and then a 1, or 10 to the minus 6.
Are you going to go with the 10 to the
15. And then there'll be 2 more after that. Nanometer. Okay, do you guys want me to keep going to decimals or just switch to scientific notation? Anybody want decimals? Okay. All right, I'll give you this one with the decimals. So it's 0 point, it's going to be 8 zeros and a 1. 0, 0, 0, 0, 0, 0, 0, 0, 1 meters, or 10 to the minus 9. And for the last two, I'll just write it in scientific notation. The zeros are getting annoying. All right, I'm going to get rid of this. All right. Anybody know what the next one is? Nah, I skipped that in between here. I'm going to throw it in at the end. So next one is picometers. Never heard that one before. And I'm not going to put all the zeros, but it's 10 to the minus 12. If you prefer writing decimals, it's a decimal with 11 zeros and then a 1. So 11 zeros after the decimal and a 1.
Is the P supposed to be capital?
Lowercase. I think it's lowercase. Picometers? Pretty sure it's lowercase. Why? Did you see a capital somewhere?
Well, the N. Is...
Yeah, nano is capital. Pico's lowercase. And the last one, I'm sure you've never heard of this, is femtometers. And that's 10 to the minus 15. And again, if you really like to torture yourself and write out decimals, it would be a decimal with 14 zeros and a 1 afterwards. That's pretty strange. All right, so I got two more that I'm going to throw in here, and these two don't fit nicely. And to see how we're going, each time we divide by 1,000, right? The exponent goes down by 3. These two didn't fit nicely into that. And they are centimeters, or 0.01 meters, or 10 to the minus 2. And the other one, this last one, only applies to distance. And this last one's called an angstrom. And an angstrom is 10 to the minus 10 meters. Okay, so why do we have these two extra ones? So centimeters were created because they're an easy unit to measure small things you can measure in your hand, right? A textbook, something like that. You wouldn't want to measure it in meters, but you wouldn't want to measure the length of this textbook in millimeters either. It would be like 400 or whatever it would be. So centimeters are useful for a lot of things. Angstroms were created because they're the width of an atom. Atoms are measured in 1, 2, 3 angstroms, so that would be the width of them. So that's why we have this unit. And angstroms, like I said, only apply to this distance. We don't have them for other stuff. Okay. Now I'm going to tell you something, and I'm going to repeat this a whole bunch of times over the next few weeks. But if you get it this time, things will be really good. So please, please understand this. Whatever I have written here applies to every other unit. So you notice here it says 1 kilometer equals 1,000 meters. Well, that means it's also true that 1 kilogram equals 1,000 grams. It's also true that 1 kiloliter equals 1,000 liters. So these prefixes apply to everything else. 1 kilo something always equals 1,000 of that thing. 1 micro something always equals 0.000001 of that thing. So these prefixes, all you got to do is take out the M and switch it for grams, seconds, watts, whatever it is, and it'll be the same numbers. 1 kilowatt equals 1,000 watts. So if you get that, and then I give you a worksheet, and it doesn't say meters, it says grams or something, you just substitute in these things, just take out the M's and put something else in there. It'll always be the same numbers. Does that make sense? All right, good. Now I need space to write. Is everybody? Huh? The middle?
Left.
Actually, wait, no, I want to leave that because I'm going to keep referring to it. I'm going to erase the left. Does everybody have this here? Anybody not have it? Tell me now. We'll never get another chance. All right. Okay, so let's do some problems. So I've been debating for years now if I want to write down the steps or not. But I'm just going to do problems because I like doing it better that way. Okay, so let's say we want to convert 47 meters to kilometers. Okay? All right, so this is how you convert. You write down the number that you have, 47 meters. And make sure you write this down. This is the only way to convert. If you put parentheses, you always do this. Draw a line through the middle, like there's going to be a fraction. Whatever units you see out here, those units go on the bottom. I don't care about numbers, we're concerned with units. You write those units on the bottom. Whatever units you're converting to, that goes on top. Actually, it's going to get sloppy for a bit. Once you have the units written down correctly, the problem will do itself for you. Now all you have to do is refer to your table over here, and you look for the right one. Kilometers to meters, that's this one here. 1 kilometer, write 1 next to kilometers. There is no rule that the 1 always goes on top or that the 1 always goes on the bottom. That is not a rule. The 1 can go on top or bottom. Whatever it says here is what goes next to those numbers. Here it says 1,000 next to meters. Here you put 1,000 next to meters. These two numbers should read the same as these two numbers here. From here, all you have to do, 47 times 1 divided by 1,000. Obviously, you're not going to multiply by 1. So 47 divided by 1,000, you plug that into your calculator, should give you 0.047. And these meters cancel, and you get kilometers as your units. That's your answer. Every conversion, even if you're not doing metric system, can be done this way. And it always works, and it will never go wrong. Questions? All right, let's do another one. Let's do 205 micrometers to meters. As always, we're going to write down whatever number we're given with its units, 205 micrometers. Next step is to draw parentheses, put a line through the middle. What units are going to go on the bottom? Micrometers. Whatever we have on the outside, that's the unit that goes on the bottom. What unit goes on top? Meters. So here we go. 1 micrometer equals all that number of meters. So 1 micrometer. And then here it says 0.000001 meters. So all you gotta do is 205 times 0.000001. Who's got a calculator? You could do this without a calculator, right?
Yes, and zeros on
All right, so 0.000205. And don't forget your units. Micrometers cancels, so this is in meters. All right, let's do another one. Let's do something that's not distance. Let's say convert 37 nanograms. I should write bigger. 37 nanograms to grams. Okay. So before we start writing this problem down, make sure you know which one we're doing. Well, all right, so this is the one we want, this here. Nanometers to meters, it's going to be the same as nanograms to grams. So we could rewrite this one, and I'm going to rewrite it up here. 1 nano, let's take the M away and put a G, gram equals 0.00000001 grams. So this is the one we're going to use to convert. Okay, so before I even write the problem out, make sure you know which one you have. So this is the same as this, I just made it into grams instead of meters. All right, so 37 nanograms, grams go on, oops, nanograms go on the bottom, grams go on top, and then you just get your numbers from here. 1, 0.000000001. If you don't put the units inside the fraction, you won't know which number goes on top or bottom. Always write the units first and have this written down, and then know where the numbers go. All right. What's this come out to? 3.7 times 10 to the minus 8? Is that what that is?
6.
Or if you want it as a decimal, it's going to be 0.000000037.
Yeah, it's 6 zeros.
I put one extra. Seven?
Yeah,
I did?
3 zeros.
Okay. That many?
Should be one more.
My calculator says 6 zeros.
It should be 3.7 times 10 to the minus 8. Right? Which should be 3, 6, 7, 8. So it should be 7 zeros. You might have, when you type this in wrong, you might have lost a 0.
Well, no, I put 10 to the negative 8.
Oh,
Then I
well,
multiplied it by 3.
10 to the minus 9.
Oh.
Yeah, so there you go. Okay, so it should be 3.7 times 10 to the minus 8. And then your units, of course, are grams. All right, questions?
Wait, how come you didn't do 10 to the negative 9?
I did. See this here? Let me erase this. Put grams up here, 10 to the minus 9. 37 times 10 to the minus 9. And you'll see it'll come out to this. Okay. What else?
Like, say we do problems like that, would we be able to put them like that instead of putting all the zeros?
Absolutely, yeah. You can always use this instead of this long thing. Yeah, either one. All right, one more? All right. Okay, let's say I want to do 200 nanoseconds. What's example 4? 200 nanoseconds to, no, not nano, I already did nano. Oh, sorry, you guys are doing math on reassumption. Let's do microseconds. Microseconds to seconds. All right. So it's not meters, it's something else. So we got to write down what it is. So this is micro, right? Right here. So 1 micrometer equals that many meters. So we could just rewrite this again as 1 microsecond equals 10 to the minus 6 seconds. Okay? So that's our conversion right there. All right, so 200 microseconds. Microseconds goes on the bottom, seconds goes on top. And now we just get our numbers from here. 1 on the bottom, 10 to the minus 6 on top. So what's the answer going to come out to? 2 times 10 to the 4, to minus 4. Seconds. 4.0002. All right, show of hands. How many people think this is okay? You're good with this? You understand what we're doing? All right, how many people are lost? Need me to do some more problems? Want to drop this class? Okay. Should I do another example or are we good?
You do one more for me.
One more. All right, we'll do one more. Last one. Let's do 47,000 kilometers to meters. Okay, so this one I put in distance again, so we can just, we can use the ones that are going here. So here we're going to do 47,000 kilometers, parentheses, kilometers go on the bottom, meters on top. We always just look, there it is. 1 kilometer, 1,000 meters. What's that come out to? Just 47,000 times 1,000, right? Divided by 1. Or so that should be 47 million, right? 1,000 times 1,000 is a million. So there we go. All right, I'll stop here. So you guys have time to work on this. Rocco, would you do the honors, please?
Sure.
Thank you.